Use the definition of a derivative to find the equation of the line tangent to the curve f of x equals 3 times the square root of x at x equals 4. Step 1. Apply the definition of a derivative to the function to get the slope function. For reference, I'm going to write the definition of a derivative right here. It's the limit as h approaches 0 of f of x plus h minus f of x all over h. And so I'm going to apply that to this function. So I'm going to come work over here. I have the limit as h approaches 0 of 3 times the square root of x plus h minus 3 square roots of x all over h. To simplify this, I'm going to multiply by the conjugate. The conjugate of this numerator is the exact same thing, except there's a plus sign in it. I'm going to apply that on the top and the bottom because I need to multiply by a 1. To multiply this, I'm going to multiply the first term by the first term over here. 3 times 3 is 9, and square root of x plus h times the square root of x plus h is the quantity x plus h. Next, I'll multiply this first term by this last term, and this last term by this first term. And when I do that, what happens is this is the positive version, and this is the negative version of this term, and this is the whole reason why I multiply by the conjugate, because these two terms will cancel. So I'm not going to write that down because I don't need to. And now I'm going to multiply negative 3 square roots of x times 3 square roots of x. That's negative 9x. And now on the denominator, I have h times 3 square roots of x plus h plus 3 square roots of x. Now I'm going to distribute on the top 9 times x and 9 times h, so I have 9x plus 9h minus 9x over this entire denominator. And this is where the magic happens. 9x and negative 9x will make 0, so I'm just going to erase those items. And h divided by h makes a 1, so I'm going to erase those items now. Get rid of that plus. And so now I have 9 over this denominator. Now I can apply the limit as h approaches 0 because I've dealt with all the algebra. So I am going to plug in a 0 right here. Let's go ahead and erase that as well. And so now I have 9 over 3 square roots of x plus 3 square roots of x, which is 6 square roots of x. And this simplifies to 3 over 2 square roots of x. This right here is the derivative. This is the slope function. We've just finished part 1. A quick side note on your slope. You may have gotten this, but you can also multiply by the number 1 square root of x over square root of x to get 3 square roots of x over 2x. So just know that's okay for your slope function as well. Step 2, find the slope of the tangent line by plugging in your x value to your slope function. So this is the slope function we got in the last problem. And the x value we were given in the problem is x equals 4. So we have x equals 4. And what I'm trying to find is the slope when x is equal to 4. So f prime of 4 equals 3 over 2 times the square root of 4, which equals 3 over 2 times 2, which equals 3 over 4. This right here, this 3/4, is the slope of your tangent function. Step 3, find the point of tangency. Well, we already have our x value, which is equal to 4. To get a corresponding y value, we're going to use our original function. We were given f of x equals 3 square roots of x at the beginning of the problem. So I'm going to do f of 4 to find that point of tangency. So 3 times the square root of 4, which is 3 times 2, which is 6. So the point of tangency between our curve and our tangent line is 4, 6. Step 4, and our last step, is to write our tangent equation using our slope and point. This right here is our slope, and this right here is our point. So I like to use graphing form of a line to help me write the tangent function. So that's y equals m times the quantity x minus h plus k, where hk is any point on the line. So this right here is going to be our h, and k is going to be 6. So I'm just going to fill in all the information. Y equals our slope, 3/4, times the quantity x minus 4 plus 6. This right here is the tangent function to our curve. Want to check your answer? Using Desmos is a great tool. What I have here are 3 things typed in. I have the original equation, graphed in red. I have the slope function, graphed in blue, and I have that point of tangency. Looking at this graph, I can see that the blue line just grazes the red curve, so I know I did this right. I hope this helped you with derivatives and lines of tangency.